Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about relationships among the functions, the trigonometric functions. And so the objective is to simplify expressions, trig functions, and expressions, and to prove trig identities. All right, so just to go back, this should be a review for you. So reciprocal relationships means, in this case, 1 over sine is equal to cosecant theta. 1 over cosine theta is equal to secant theta. 1 over tangent theta is equal to cotangent theta. Right, relationships with negatives. So what happens if we take a negative angle measure? I have an angle measure here, and now I turn that angle measure into a negative angle measure. What happens to each of the values? So we can see if the angle measure is negative for sine, and it becomes negative sine theta. So if I take an angle measure and I change it to a negative angle measure, you can see that for sine, since now I'm going to be in the third or fourth quadrant with this angle measure, then it becomes negative sine of theta. So anything with a y value in it, in this case, or anything that has a relationship to sine, is now going to be changed from sine of negative theta, or a value trig function of a negative theta, to negative sine, negative cosecant, negative tangent, or negative cotangent theta. If I'm referring to x or anything with cosine but without the sine, so cosine and secant, cosine of negative theta is just going to be cosine of theta. So if I take this example, and this will hold true for any theta, but it's easier to see for this acute angle. I have theta and then negative theta. You can see that cosine remains positive in the first and the fourth quadrant. So cosine of negative theta is just cosine of theta. As another example, if I take cosine of negative 95 theta, so negative 95 theta is the same as cosine of 95 theta, which will be a negative value, but the same as in sine, cosine of negative 95. All right, so we're going to do some classwork. I'm going to pause here while you evaluate or rewrite these negative angle measures. All right, so you should get cosine of negative theta, negative 90 degrees is the same as cosine of 90. Tangent, so it has a sine value, so to speak, in. Tangent is negative tangent 130. Sine of negative 200 is negative sine 200. Secant, negative 50 is secant 50. So this has just cosine reciprocal of cosine. So secant of negative theta is just secant of theta. All right, so now we're going to talk about our Pythagorean relationships. So we're going to remember back to our geometry days. The Pythagorean theorem says a squared plus b squared is equal to c squared. So the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And now we're going to relate this to a unit circle in which the hypotenuse now is equal to 1. So in this case now x squared plus y squared is going to be equal to 1. Now I can rewrite sine of theta as y over 1 and cosine of theta as x over 1. And so cosine of theta x over 1 is equal to x and sine of theta is equal to y. I can take a look at what I had written in the prior slide, x squared plus y squared is equal to 1. Knowing that sine of theta is equal to y and cosine of theta is equal to x, I can now rewrite this as from x squared plus y squared is equal to 1 to cosine squared theta plus sine squared theta is equal to 1. And so this is our first Pythagorean relationship. All right, so I can take this first Pythagorean relationship and then also write the next two, and that's going to be your assignment for now, is to use the first Pythagorean relationship, sine squared theta plus cosine squared theta is equal to 1, and rewrite it as tangent squared theta plus 1 is equal to secant squared theta, and cotangent squared theta plus 1 is equal to cosecant squared theta. All right, so I'm going to show you how to do that. Tangent squared theta plus 1 is equal to secant squared theta. So I can write tangent squared theta is equal to secant, or sine squared theta over cosine squared theta, and secant squared theta is equal to 1 over cosine squared theta. And 1 is just equal to, well, we're going to say cosine squared theta over cosine squared theta. So I have tangent squared theta as sine squared theta over cosine squared theta, plus 1, which is cosine squared theta over cosine squared theta, is equal to secant squared theta, which is 1 over cosine squared theta. I can multiply all of these values by cosine squared theta, and I end up with sine squared theta plus cosine squared theta is equal to 1. For the third identity, cotangent squared theta plus 1 is equal to cosecant squared theta. I can rewrite cotangent squared theta as cosine squared theta over sine squared theta, and cosecant squared theta is equal to 1 over sine squared theta. So I have cotangent squared theta, which is cosine squared theta over sine squared theta, plus 1, which I write as sine squared theta over sine squared theta, is equal to 1 over sine squared theta. Again, I multiply all the terms by sine squared theta, and I end up with cosine squared theta plus sine squared theta is equal to 1. All right, so I want you to take a moment and simplify, rewrite these simple expressions. I'll pause for a moment. All right, so for these you should get cosine squared theta for number 1, and we're just using the identities here. Tangent squared theta is equal to number 2. Cotangent squared theta is equal to the third one, and the fourth one is secant squared theta. So I know that sine squared theta plus cosine squared theta is equal to 1. If I rewrite that, it's 1 minus sine squared theta is equal to cosine squared theta. I know that tangent squared theta is plus 1 is equal to secant squared theta. So secant squared theta minus 1 is equal to tangent squared theta. I know that cotangent squared theta plus 1 is equal to cosecant squared theta. So cosecant squared theta minus 1 is equal to cotangent squared theta. And then the last identity, 1 plus tangent squared theta, is equal to secant squared theta. All right, so cofunction relationships. We're just going to breeze through this real quickly. Sine theta is equal to cosine of 90 minus theta. Cosine theta is equal to sine times 90 minus theta. Secant and cosecant are cofunction relationships. Cosecant 90 minus theta is equal to secant theta, and cosecant theta is equal to secant 90 minus theta. And then same with tangent theta. Tangent theta is equal to cotangent 90 minus theta, and cotangent theta is equal to tangent times 90 minus theta. All right, so this is a summary of everything that we've learned. I'm going to pause for a moment if you want to rewrite this. You also have your cheat sheets to refer to. All right, so now I want you to simplify the cofunction relationships. I'll take a moment and pause. All right, so cosine 90 minus theta is equal to sine theta. Secant 90 minus 20 is equal to cosecant of theta. In this case, this is the theta, 90 minus 20. So cosecant of 20. Cotangent 60 degrees is equal to tangent of 30 degrees. Tangent 55 degrees is equal to cotangent of 90 minus 55, or cotangent of 35 degrees. All right, so now I want you to simplify and rewrite these. I'm going to take a moment and pause. All right, so the first one, 1 minus cosine squared theta is equal to sine squared theta as I FOIL this. Second one, I FOIL this, secant squared theta minus 1 is equal to tangent squared theta. And then the last one, I get 1. So 1 over sine squared theta minus 1 over tangent squared theta, which is cosine squared theta over sine squared theta, leaves me with 1 minus cosine squared theta, which is sine squared theta, over sine squared theta, which is equal to 1. All right, some more difficult problems. I'm going to post these and then I'm going to show you the answers and move on. You're going to have to pause to review how I got to the answers. So take a moment to finish this problem. And then here is the answer. It's equal to 1. Next problem. And pause for you to complete this answer. And the answer is sine of b. And I'm going to pause as you evaluate the answer. Next problem. I'll pause here for you to complete the problem. And then the answer, so this turns out to be a complex fraction. So we split this into the numerator, which I rewrote, and the denominator, which I rewrote. And then we take the numerator to simplify. We find a common denominator. And then as part of that process, we end up with a value for 1 in the numerator. So I have a numerator and denominator of the original numerator times the reciprocal of the denominator. And you end up with cosine over sine, which is cotangent of x. Next problem. Pause here. Right, pretty straightforward. 1 over cosine x minus sine x times sine x over cosine x. The same as 1 over cosine x minus sine squared x over cosine x. 1 minus sine squared x is equal to cosine squared x. Cosine squared x over cosine x is equal to cosine x. And then the last problem, cotangent A times 1 plus tangent squared A over tangent A. And we're trying to prove that's equal to cosecant squared A. So we take cotangent A, 1 plus tangent squared A. We rewrite as secant squared A over tangent A, which I can rewrite as cotangent squared A times secant squared A, because tangent, 1 over tangent is the same as cotangent. So cotangent times secant squared leaves me with cotangent A times secant squared A, which I can rewrite as cosine squared A over sine squared A times 1 over cosine squared A. Cosine squared A over cosine squared A reduces to 1, so I'm left with 1 over sine squared A, which is cosecant squared A. All right, so that's it for chapter 8.4. Thanks for joining us as we evaluate relationships among the functions. And the next will be more difficult trigonometric expressions and equations in chapter 8.5 in the next edition of Autumn Math.